Welcome to my creative demo world. Wes here, and if you're interested in monostable circuits and T flip-flops, you're probably an advanced Minecraft user, so I won't bore you with why these things are essential building blocks for redstone devices. We'll just get right into it. This is the first one we're going to look at here. In this device, the signal comes around, and because it's going into the side of that repeater there, it gets cut off, so nothing happens. But when we shut the power off, the repeater on the right will stop powering the one in front of it, allow the signal to travel through it, and we'll get a brief pulse that will go through to the lamp. I just showed you that in slow motion. Okay, so this is called a falling edge monostable circuit because it lights the lamp, or allows the signal to go through it, when the control signal into it stops or is cut off. Now what's really nice about this design is it's incredibly flexible. Watch how short this pulse is here. You can adjust the pulse length in a number of different ways, and allows you to drive different devices that require different pulse lengths with really minimal adjustment. So we saw how quickly that one went, that pulse was. This is a way to make the pulse rather long. So I'm just going to line up a bunch of repeaters here, put them all on full delay, and then you'll see what the comparison was to the one that we just did. So here we go. I've used this thing in a number of different places. Look at how long that one's lasting. Fantastic. Now, you typically wouldn't use this many repeaters, but I just wanted to show you the concept of how to change the delay. But what's really nice about this is if you set these two repeaters, oops, redstone didn't disappear, that's interesting. If you set the two repeaters side by side like that, and they're both on 1 tick delay, this thing can be used to drive other devices, and one of that's really nice is that you can make T flip-flops because the signal comes through so fast. So what we're going to do here now is show you that, oops, I got to put another dab of redstone over there behind that other repeater. Put that down. This signal comes out so fast that the block doesn't have time to update and pull the block back. So this is the beginnings of how to make a T flip-flop. Notice the block is stuck out there, okay, in space. The piston just didn't have enough time to pull it back. So I'm going to show you a real simple concept of how to make a T flip-flop with this. Drive the signal through where the block is. Put a lamp over here. Okay, and because this signal is so fast, the block will go over and be held either out or back, depending on the sequence which you push the button. So for example, here you go, push the button, it pulls it back, and your lamp lights, or your bridge opens up, or your door opens up, and then you press it again, okay, and it closes. Excellent. So now, just to show you, if you were controlling something like a bridge or a door or anything else, you can have your buttons on either side of it. Okay, this is typically how you would control a bridge. Okay, so I got to put a repeater in here because the signal's a little bit long here. Okay, so you get your button on one side of your bridge or your door, get your button on the other side, you can press the button and the door or bridge opens or closes, however you have it set up. Press the one on the other side and it reverses. That's a T flip-flop. Okay, now I showed you that in that manner there because I wanted you to see how the signal travels through the block, but typically this is a little bit less expensive and simpler way to make the signal come out. Okay, so you just put the redstone torch down underneath it and it achieves the same thing. So that's a nice monostable circuit that can be adjusted in length and quickly converted into a T flip-flop. Now we're going to go look at one that is really inexpensive that's based on the concept of inverters. Inverters are made by putting a torch on the side of a block like this and then powering the block. When you put power into the back of that block, the redstone torch on it shuts off. And then here, if you delay the signal coming through the repeater, briefly what will happen is the lamp or the circuit will shut off. So here it is in slow motion. So we put power into the device, okay, and then the torch shuts off. Excellent, okay, and then it powers back up again because the signal's coming through the repeater. Now, if you want to make it so that you get power, a quick pulse into whatever device you have, when you put power into the back of it, you just put an inverter here. So here's where your lamp or your piston or whatever, okay, it would be off, okay. So when you put power back in the back of this thing, it just pulses on. you can do these kind of, here it is in slow motion again. Okay, so power off, put power into it, everything shuts off, the lamp lights real quick, okay, and then it shuts off. You can use these kind of inverters everywhere. Okay, but I want to show you that if you put this thing on really short, okay, the inverters don't work too good. Okay, so there's nothing coming out of this thing. So there's 2-tick delay, still nothing happens. Okay, so you put it on a 3-tick delay, and I think we might get a little pulse here. Let's see. Yeah, quick pulse there. Okay, so that just shows you that the signal length on these is a little bit less controllable. So let's throw a piston down here and see if we can get the same kind of thing that we had happen on the previous device. It's actually kind of unique here what happens with this. You can't really hold the block out, but I'll just show you what happens. Okay, so here we have no delay on the repeater. Look right here. I'm going to do this in slow motion. Watch what happens to the piston. Very quickly, you see that piston just barely starts to fire. So this device, it's too quick to hold the block out and make a T flip-flop out of it like we did on the other one. Even if we set it, see, we set it on 2 ticks delay and the block doesn't stay out. It's really fast, but it's not as fast as the one we did before. Now the length of the pulse can be adjusted in a similar manner to what we did on the previous device. So I just put a bunch of ticks on that repeater. I can throw down a few more over here, and we'll make it so that the pulse length is a lot longer. Same kind of thing we did before. Set these things all on full delay just to show you how it works, and shut the signal off. And then we put power into the back of it, it shuts off for a lot longer. Okay, now I think what I'll do though, just to show you, is invert this signal on this side, and then show you that when you put power into it, you can get your piston to hang out for a really long time here. So one more time, we'll take a look at this. Okay, piston shuts off for quite a long time, but if you happen to want to go the other way, we'll just throw an inverter down right here and just kind of give you a quick illustration of how that works. There's your inverter, little redstone maybe here, and then we'll throw a piston down. So I found this design to be pretty reliable, relatively flexible, and very inexpensive. So one more time, this will just, when you put the power into it, the piston will stay on for quite a bit. So a good example of a rising edge monostable circuit, but I haven't figured out how to time this device to make it so the block stays off of the face of the piston yet. So I can't really use this for T flip-flops like we did with the other one. So now we're going to look at another design that's based on inverters and repeaters, just like the one we just looked at, except this one's 2 blocks high instead of 2 blocks wide. So you just use this similar to the other one, but if you have a different packaging configuration. So same concept as the other one. When power goes into the back of it, the torch shuts off and the output signal is cut off briefly. So here it is in slow motion, just like we did in the previous one. Power's off now. When I put the power into it, the torch shuts off, and that repeater slows the signal back down, and it cuts everything off briefly. So you can put an inverter in here, just like we did on the other one. The signal extension is a little bit different on this one, though. You have to put another block up on the top here, and then put the repeaters down underneath it. So it's not quite as flexible as the previous one, but I've actually used this one more in my world. It just fits better in some applications. So you put the repeaters down underneath here, put them on the high delay. Make sure you put redstone on the top of this to power that block off, or shut that torch off. And then once again, shut it off, power goes into it, and we get a slightly longer delay in the signal. And you can put inverters out here just like we did in the previous one. That's a handy little monostable circuit you might be able to use in your world. Now we're going to go off and take a look at one that's based purely on pistons. So in this one here, we drive the signal through the block on the top. I put the redstone lamp on the top just to show you how it works. It goes through there, okay, and then actually because it's hitting that, it actually powers the piston right underneath it. So the signal goes through that real quickly, okay, until the piston fires, and then it gets cut off. So we're going to get a real short pulse into that lamp over there. So here it is in real time. power into the block on the top, real quick pulse on the left. Now I'm going to show it to you in slow motion. Notice that the lamp on the top lights real fast, okay, and then the signal goes through it, okay, piston fires up, okay, and then we get a short pulse out the back side. So the nice thing about this one is that the duration of the signal is just about perfect for making T flip-flops. So a lot of people use this for T flip-flops. So I'm going to show you how most people set this up. Now I've been using the word piston throughout this video. I hope you know I've been using all sticky pistons for every one of these little devices. So you can put your sticky piston in the ground like that. You put your repeater over here to drive the signal into the block that's on top of it. You don't need to use this redstone lamp, just use a block, okay? And then the signal comes out of the back side, and very quickly you've got a little monostable circuit. So here it is in slow motion again. We put the power into it, goes through the block on the top, fires up the piston, and then shuts off real quick. Okay, now I'm going to show you how to take this and turn it into a T flip-flop. Very similar to what we did before. The duration of the signal is perfect for this. So I put our little sticky piston over here, put a block on the face of it, and just like we did before, when it comes off, it's not going to be able to pull back. It's just the perfect timing to make it so that the piston doesn't update fast enough. So just like we did before, we'll put a little torch underneath this, take the signal out of the back side of it, and we've just got ourselves a real simple T flip-flop. So just like on the first device we built out of the repeaters, when you put power into it, it changes state. So if you're going to control something here, you put your button down, run your signal off to the other side. It just, when you hit your button, it's either going to go on or off. So just for fun here, I'll run a little circuit out over here. This is what you would do if you were, put this on the other side of your door or your bridge or whatever the heck you're trying to control. And so you hit one, turns it on or off. Hit the other one, it changes the state. Now I'm going to show you a way to do this that is just a little bit more compact. Okay, so we're right here. We're going to throw a piston down. No, that's the wrong place for the torch. Hold on, we got to put the torch over here, one to the right of that here. Hang on for just a second. Okay, so that's where we're going to take the power out. Just going to throw a block down in there. You just leave your dirt or whatever in there. Okay, and then we're going to take our sticky piston and come right off of this. So the signal's going to come right through that redstone lamp, which would normally just be a block. Okay, and it'll power this sticky piston. Okay. And we'll put a block on the face of this sticky piston, and there will be our T flip-flop. So here, this is pretty compact. So let me just clean up this stuff here. So we've learned about 4 different monostable circuits, 2 of which can be easily converted into T flip-flops. Whether you use this design or the previous or the first one with the repeaters is a matter of personal preference or whatever fits in the package that you're working on. I hope you enjoyed this video. This is Wes, and I'm out.